Assalamualaikum and hi everyone. Welcome to our video presentation of Chemistry 256 about direct titration. Before we start, I would like to introduce our group members. First, me Elisa Adriana binti Abdul Syukur, and we have Irdina Zarid Sofia Jalani, we have Muhammad Daniel bin Azman, Nur Amisha Alila binti Zulfakri, and Nur Liana Afika binti Azmi. In this video, we are going to talk about the introduction of direct titration, explanation of the application related to the chosen topic, methodology, example of the result, and conclusion.
What is direct titration? Direct titration is a common analytical method in chemistry used to determine the concentration of an unknown solution. In this technique, a solution with a known concentration, called the titrant, is added directly to the solution of unknown concentration, known as the analyte, in the presence of a suitable acid-base indicator. The titration proceeds until the reaction is complete and reaches the equivalent point, which is typically detected by a visible change such as color shift from the indicator or a sudden change in pH. The volume of titrant required to reach the endpoint when the indicator changes color is measured and used to calculate the concentration or amount of the analyte. Purpose of direct titration. Direct titration is used to determine the concentration of a specific substance in a solution by gradually adding the titrant of known concentration until the reaction reaches a defined endpoint. This endpoint is typically identified by a color change when an indicator is used, or by achieving a specific pH value in acid-base titration. There are 4 points for the direct titration. First is quantitative analysis. It enables accurate determination of unknown concentration in a sample. Second is reaction completion. Confirm that the chemical reaction has proceeded to completion, which is crucial for precise concentration calculation. Second last is versatility. It's applicable to a wide range of reactions, including acid-base, redox, and complexation reaction, as well as analyzed in pharmaceutical and environmental effects. Finally, quality control. It is widely used in laboratories and industrial settings to ensure products comply with required concentration specifications.
So, when to use the direct titration? Direct titration is used when the reaction between the analyte and titrant is fast and the endpoint is easily determined, either visually or instrumentally. It is the most straightforward titration method, involving the direct addition of a titrant with a known concentration to the analyte until the reaction is complete. Here are the theoretical equations for direct titration. Analyte plus titrate equals to product. And one of the common examples is quantification of acetic acid in vinegar. Now, let's move on to the theory part of the video.
Acid rain or acid deposition is a broad term that includes any form of precipitation with acidic components such as sulfuric or nitric acid that falls to the ground from the atmosphere in wet or dry forms like snow, rain or fog, or in dry form like gases and particles. Normal rain has a pH of about 5.6 and it is slightly acidic because carbon dioxide dissolves into it, forming weak carbonic acid. But acid rain usually has a pH between 4.2 and 4.4. In theory, the acidity of rainwater can be precisely determined by neutralizing it with a base of known concentration. This process is known as titration, which involves the controlled addition of a strong base such as sodium hydroxide to the rainwater sample. To identify the equilibrium point where the acid and the rain sample is completely neutralized, a pH indicator like bromothymol blue is used. Bromothymol blue undergoes a distinct color change from yellow to blue as a solution transition from acidic to slightly basic, signaling that the neutralization is complete. By accurately measuring the volume of standardized base required to reach the endpoint, we can then calculate the original concentration of the acid and the rainwater sample, providing a quantitative measure of its acidity.
Hi, my name is Nur Amisha Alila, and I would like to present about what methodology of our topic. For our topic, we use two methods. The first one is sample collection of rainwater. This experiment, we use only a clean container for the equipment. The first procedure is place the container in an open area away from overhanging trees or structure that could interfere with rainfall. Second, ensure the container is clean or free of any contaminants. Third, carefully transfer the collected to rainwater into a clean bottle for analysis or storage. The second method is titration process. We have 6 procedures for this titration process. First, a known volume of rainwater sample is pipetted into a conical flask. Second, a solution of sodium hydroxide and NaOH of known concentration is added to the sample slowly using a burette. Third, a pH indicator, bromotyl blue, is added to the analyte. Fourth, the titration process is present done when the color of analyte changes color from yellow to blue. 5. The volume of NaOH solution required to neutralize the acid in the sample is recorded. And the last one of the procedure is this volume along with the concentration of the NaOH and the volume of rain sample is used to calculate the acidity of the rain.
Now let's look at the results.
For example result, visually demonstrates the key outcomes of the titrations on the right. Rainwater samples with indicator before titration display colored yellow. On the left, the same rainwater sample after titration has been completed have reached their equivalence point, and the color change to blue indicates that the acid in the rainwater has been successfully neutralized.
To conclude, this titration experiment provides valuable data for environmental monitoring. By analyzing the acidity levels, scientists and policymakers are able to better understand the severity of acid rain in specific regions. This information also helps track changes and trends over time, allowing us to see whether conditions are improving or worsening. Most importantly, the results can be used to assess how effective current mitigation measures are in reducing the harmful impact of acid rain on ecosystem and infrastructure. Overall, this study highlights the importance of accurate chemical analysis in protecting the environment and supporting informed decision making. Here are some of our references. Thank you for watching our video presentation.